Good morning guys, just like I promised to explain how the new tester I designed works. This is the tester. I call it a pocket tester, a pocket multimeter. Now this tester is able to test transistor, diode, continuity testing, and also it has an inbuilt power of 3.7 voltage, and also can take an external power from ranging from 3.7 volt 2 amp to 24 volt 2 amp. It also comes with a probe. This probe, you can make it out of anything, you just have to think. It's not everything I'm going to explain, so you just have to think. You can make this probe out of anything. The input of the probe is a USB, a male port, and a big pin male port. So it's as simple as that. Let's move on explaining and seeing how it works using the circuit diagram. Okay guys, this is the circuit diagram on the board, as you can see. Now we'll begin from the transistor testing part of the circuit. This is the transistor testing part of the circuit. This part. If you look at it very well, you see a 1K resistor, you see a 10 ohms resistor. And then this is the 3 pins where you plug the transistor in. Now, this particular part uses a very simple principle, the normal principle that governs the working of a transistor. That's what this particular part uses. How does it work? You have the 3 pins, just as, imagine the 3 pins here is your transistor. And then you have the collector, the base, and the emitter. Looking at the base pin, it's looped to 2 resistors. These 2 resistors, one of it, the one with a 1K ohms resistance, is looped to the negative terminal of the source. This is the source terminal, this is the positive and negative. And then the other 10 ohms is looped through a button switch to the positive terminal of the source. Now what happens is that whenever you plug in your transistor, the emitter of this transistor is looped to a buzzer passing through 100 ohms. So whenever you plug in your transistor, since we have a constant negative charge connected to the base through this 1K ohms connected to the base, a constant negative charge. So let's assume that the transistor is an NPN transistor. So when once you plug in your transistor, we have a constant N. So it is an NPN, which means the transistor communication between emitter and collector remains off. Why? Because of the constant negative charge at the base. Understand that an NPN transistor requires a positive charge at the base to allow communication between the collector and the emitter. So we have a constant negative charge to the base, and then the resistor that has the positive charge, which is the 10 ohms, lower in resistance than the 1K, is connected through a button switch. Now when you plug in this transistor, to know if this transistor is working, you have to press the button. By pressing the button, allow a positive charge to pass directly to the base. Since the resistance between the positive charge and the negative charge is not the same. The positive charge, the resistance at the positive charge is lower than the resistance at the negative charge. That's, I'm talking about the resistor, the 2 resistors here. So when you click, it allows the current flow directly from the positive source to the base. And then because of difference in current level, the current at the positive side will overshadow the current at the negative side and then turn the transistor on. From there, the beep sound comes on, completing the circuit. So that's how it works. It's very simple. So once you release this button, the transistor goes off again. That means the transistor is working. But in a case where you use a PNP, you know that a PNP requires a negative charge at the base to turn on. So whenever you plug in the transistor has to give a constant beeping sound. So how do you know that it's working? Is by the time you click the button right here, it sends in positive charge to the base, overshadowing the negative charge as it happens using an NPN, and then it will turn off the transistor. So once it happens like that, know that the transistor is working. So let's move to the other part of it, which is the continuity testing part. It's very simple section. Now, this is a big pin female port. This big pin female port is directly connected to the emitter and the collector of the transistor testing pins. So whenever you plug in insert your probe, you can use the other ones to test whatever you want to test based on continuity. You can also use it to identify spoiled electronic components on a circuit board. So that's all about it. The rest of the part is very simple. It's the charging section that charges the inbuilt battery, and then the other part is the charge indicator. So it's as simple as that. This is the tester. Looking at this place, you see about 7 pins. The middle pin, that's between the first 3 and the last 3, is neutral. So we are not using that one. Now, we are going to use the first 3 pins. Looking at it, you see a label. You see a label B, E, and C, which is the name of the transistor pins. This is the base, emitter, and the collector. So we are going to turn the tester on and then try testing this transistor if it works. First, it has a switch by the side. The tester is on, that's the indicator. So I'm going to plug this tester right inside. And then remember, we don't know what type of transistor is this. Neither do we know if this transistor is working. So I've plugged it into the port and we have no bit. I have to inject the positive charge. Okay, it's beeping, which shows that the transistor is working. And since it requires positive charge to turn on the transistor, it simply means that this transistor is an NPN transistor. This is the MOSFET transistor, NPN. So that's how it works. It's as simple as that. The transistor is working. So let's look at the continuity testing aspect of it. Now, like I said, this is the big pin female ports, and this is the probe. So all you need to do, insert it to the female port, and you have your continuity tester. So with this, you can test any electronic components and identify if it's working or not. And then the USB port is connected to the USB female. This one has a direct 3.7 volts out from the tester. That's the internal voltage of the tester. If you can see, you can look at it very well. You see a spark. You see that spark. That is about 1 amp. So that's all about the tester. That's how it works. It's very simple.